Okay, let's do some examples of these, simplifying rational expressions. Let's start with number 3 here. So in number 3, we just have a simple fraction. You could type that in your calculator, it would give you the simplest form. But it's important to know what is happening here. You're creating an equivalent expression that represents 24 over 36, but in a simplified way. So to do that, what you're really doing is factoring the top and the bottom of this fraction. So you see 6 times 4 is 24, 6 times 6 is 36. Well, when we're multiplying fractions, we just multiply across the top and the bottom, which means we can split those up. And we would come out with, I could have divided by 12, we come out with 6 over 6, which is 1. So 1 times 4 over 6. If you look at 4 over 6, you're like, oh wait, that also simplifies. I could have divided out of 12 originally, because 4 over 6, that's 2 times 2, and 6 is 3 times 2. Okay? So you have 2/3 times 2 over 2. Well, 2 over 2 is just 1. So what I'm left with is 2/3. 2/3 is equal to 24 over 36. And we just showed that by factoring. So when you get to something like, let's do number 7 over here. When you get to number 7, you're going to factor. You're taking out some greatest common factors, breaking these pieces up until you can simplify it. So we'll leave 18 as it is. And b squared, what is b squared? That would be b times b over 54. Can we divide 54 by 18? We sure can. That's 18 times 3. And then b cubed is b times b times b. Okay? So b divided by b is 1. B divided by b is 1. 18 divided by 8 is 1. And all that we're left with is 3b, but it's in the denominator. Since it's in the denominator, that means we have to write it as a fraction, 1 over 3b. And we're done with that one. Let's move on. I'm going to do 9, and I'll also do 12. Okay? With these expressions, you're going to always just factor the top and the bottom and break it into these pieces until you see things that can divide out. Things that like n divided by n is equal to 1. Okay? So this plus sign here, really we want to get rid of that. And the way we can do that is we can break it into some factors. I guess we don't really get rid of the plus sign, but hopefully we'll see what happens here. So the greatest common factors from the numerator. We look at the numerator, then we'll look at the denominator. Greatest common factors from the numerator, 6n, we have n plus 1. Okay, this is important to think about it as you multiply it back out. If you were to distribute that 6n, you would get 6n squared, and then 6n times 1 gets you the 6n. You have to be able to multiply it back and get both of those pieces. And in the denominator, we have a 4 and an n. Okay. So we have 6 over 4 times n over n times n plus 1 over 1. Okay. You don't have to break it down like this every time, but I just want you to see that the reason we can divide the n by n is that it's equivalent to 1 in our expression. This 6/4 can simplify to 3 over 2. They both divide by 2. And so what we end up with is 3 times n plus 1 over 2. And that one's simplified. So we do have a plus sign. Let's get that highlighter back out. We do have a plus sign in here, but what we have is an entire term or an entire factor. So you're looking for a factor, the entire factor, not just an n. So you couldn't just look at this n because it's not the entire factor. This one is. That's the entire factor there. 6 is a factor, n is a factor, and n plus 1 is a factor. So you can't just look at this particular n. You have to look at it as a whole unit, n plus 1. So the only way we could get rid of that or divide it out is if we had an n plus 1 down here. But we don't, so we can't get rid of that entire term. But we do have an entire n term and an entire in the numerator and an n term in the denominator, so we can factor those out. All right, let's look at, or divide those out. Let's look at number 12. The numerator is already simplified, so let's focus on factoring that denominator. So we need factors of 18 that will add up to negative 11. That means or tells me that both of those are going to have to be a negative number, and that would be negative 9 and negative 2. So that's what we put in here. Okay, so I'm going to go back over here, a minus 9 over a minus 2, or 9 minus a over a minus 9 times a minus 2. Okay, so it looks to me like the things that might divide out are 9 minus a and a minus 9. But in the numerator we have a negative a, and in the denominator we have a positive a. In the numerator we have a positive 9. And in the denominator, we have a negative 9. Those are the exact opposites. So if you had something like negative 4 divided by 4, that would be equal to negative 1, right? Because they're opposites. 4 divided by 4 is 1. So if we have the exact same factor, they equal 1. But if we have exact opposites, they equal negative 1. So these will divide out and equal negative 1. Okay? So let me show you, I guess, another step as to why that works. So if I were to try to factor a negative 1 out of the numerator, negative 1 times what gets me 9? Times negative 9, right? Negative 1 times what gets me negative a? That would be times a positive a. So negative 1 times a gets me this negative a, and negative 1 times negative 9 gets me a positive 9. So you see now, I have an identical factor in the numerator and an identical factor in the denominator, because we could rewrite this as a minus 9 also. So those would divide to equal 1. And at the end of the day, our answer is going to be negative 1 over a minus 2. Alright, I'm going to make another video, or maybe a couple videos, where I talk about some more about factoring, some more about simplifying rational expressions, and also about restrictions on some of these functions. Well, I'm going to point at this one for right now. So what would happen if n equaled negative 3? That would be 0 divided by 5 times negative 3 is negative 15. So negative 15 plus 15, that's 0. Well, you can't divide by 0, can you? That would be an undefined. If you put that in your calculator, it's going to say undefined, which means for number 10, for example, n cannot equal negative 3. So when you have a rational expression and you have a variable in the denominator, there are sometimes discontinuities, or there are places where we don't get a value when we put in n. We get something that's undefined. So we'll talk about that more in future videos. Keep on factoring. Thanks for watching.